Hello, it's Ryan here from Ryan's Electrical Stuff. It's another day, it's another coffee machine repair. Today we're going to be looking at this Nespresso Aguila 220 manufactured by Thermoplan. Don't know if you know that Thermoplan are well known for their bean to cup fully automatic coffee machines. If you ever out and about, I'd say you're never really more than, I don't know, a mile away from one. The Thermoplan machines are used quite a lot at McDonald's, exclusively in Starbucks. All the Starbucks machines are made by Thermoplan. There's literally loads of big companies use them. But this is actually slightly different to all the rest of them. This is actually a Nespresso pod machine, which is quite odd, because these are sort of very niche, a proper massive commercial coffee machine. This is basically a black and white 3/4C combination. So if anyone's ever worked on a black and white 3 or a 4C, it's basically a hybrid of both. They've sort of taken bits of both of them, put them together to make quite a decent coffee machine actually. This one here has been dropped in because it's not foaming the milk. Now unfortunately I started repairing this and then I thought this would make a good video, so unfortunately missed some of the more interesting stuff. But ultimately, when you're doing things like cappuccino and other drinks like that, you weren't getting any foam, you were just getting milk. It wasn't even trying to foam, it wasn't doing anything. So you probably got it partially stripped down and pulled apart, but we'll overlook that. I'll tell you what the issue is and I'll show you how to diagnose it and fix it. But anyway, we haven't got this machine plugged into any water, so we can't do a cold start rinse. But what we can do is, we can already got the key in there for putting it into the service menu, so we'll flip it into the service menu quickly. And you can see that the screen has changed now on technical menu. You go up till we get to output test. Press that. I don't know how well that comes up on camera. You can see that that one's lit up. Actually, enter button. And then I'm going to press that again. Can make all the valves work. So we want to keep going till we get to milk air valve. You can see that when we press that, nothing happens on the milk air valve. So I reckon we've got an issue with the milk air valve. So what we'll do is we'll test it. So what we'll do is we'll turn the machine off. I'll move the camera around and readjust everything so we can get to the milk air valve. Not foaming issues generally tend to be that milk air valve, because really that's the issue really. If it's not pulling milk through too much or foaming too much, that could usually mean an air leak somewhere, because on these machines, I'll show you in a minute, they use push fit fittings, and what can happen is they can not quite seat properly and let a little bit of air in, and it buggers the air valve or the air mixture. I'll show you in a minute, but in the back of this machine there's like a little adjuster knob where you can adjust the amount of air. That should be around sort of 3 to 4, depending on what type of valve you've got and how the machine's working. If you've got a slight air leak, you can sort of notch it down a bit, but ultimately when they tend to get an air leak, they just don't work at all. They just don't foam at all. But anyway, I'm rambling. So what we'll do is we'll get the multimeter out. I'll flip the camera around, flip the machine around, and I'll show you where this milk air valve is. Back in a moment. So, and we're back again. This here is the milk pump. I'll just tweak it up slightly. This here is the 24-volt milk pump. Behind there you've got the milk rinse block, and at the bottom of the milk pump you've got this little solenoid valve here, and in here is a little plunger that moves up and down. So when the solenoid engages, it pulls the plunger up, and what this does is, this here is the air valve pipe, which I don't know if you can see very well, but in this bottom bit here there's like a little adjuster wheel. I'll put a picture of that up. I'll take a picture of that later and make that appear in the video. That little adjuster wheel allows the air, it's basically a restrictor to allow you to adjust the air. So what happens is air comes in here when the milk wants to, or when the machine wants to foam the milk up, opens that valve, sucks the air through, then goes out of here and then into the milk heating coil in this boiler. So this machine can do cold foam and hot foam. So what's happening is this solenoid valve here isn't making any clicky noise. So either the solenoid's dead or it's either the solenoid's dead, it's not actually generating a magnetic field to pull it. So I have no voltage to generate a magnetic field. All the little plunger inside has basically got stuck and not moving. I'll just grab the multimeter quickly. Be incredibly careful, because this bit here is the 24 volt power supply. It generates all the 24 volt rails. So this is actually a 24 volt valve. A lot of these stuff on these machines are 24 volts. The only things that aren't 24 volts are high power things. So that's things like the fridge, the water pump, the heating elements. And there's a couple other little 240 bits on there which you need to keep an eye out for. So what I'll do is I'll bring the multimeter in like so. See if we can try and get that so the camera can pick it up. So you can see when we press the test button, we're only getting about 2 volts, which isn't good. Isn't good at all, because there should be 24 volts. So what we'll do is we'll pop these wires off quickly, being careful not to touch anything. We'll stick our multimeter probes in there, and hopefully we'll be getting, yeah, so we press the test button, we're getting 24 volts, and yet when we put it on the valve, we're getting 2 volts. So that either means the valve's buggered up, or that plunger's not moving very good, and this current limiting supply, we'll stick that on ohms quickly. This should be about an 80 ohm valve, which it is, it's about 81 ohms. So what I'll do is, I've got another one of these valves somewhere, so I'll grab another one and we'll go from there. Back in a mo. I'm back again. I haven't got one of these exact same valves, but this is a 24 volt valve, so I'll see what happens with this one. So I'll press and test. Nothing seems to happen. See if we give it a bit of a squeeze. No, it's not having it, is it? So I'll get the multimeter out again. I did test it before putting it in, we're getting about 70 ohms, so it is slightly a bit more powerful, but so I don't think it'll make much of a difference really. So bring in the multimeter, getting about 2 volts again. It isn't good. It's starting to point towards a board issue, maybe the transistor or MOSFET on the board isn't switching, or not properly switching, which is dropping the voltage. What we're going to do is, next to the milk pump, got a couple more valves in there, which I will check to make sure they work. We'll do that now. Check to make sure they work. Then put that wire on one of them valves and see if we're getting a clicking. If we're not getting clicking on a good valve, so which will be the milk. That's the rinse block. So that'll be the milk rinse valve. So we'll get one on rinse valve. So we're getting a click on a valve. So what we'll do is, I'll swap the wires over, see if we get another click. Back in a moment. So I don't know where you can see that, but we put the old valve, air valve, onto the rinse valve, and put the wires for the air valve onto the rinse valve. So we'll fire the machine up, see what clicks and what doesn't click. Oh, oh no, it's just me pushing on the machine. There we go. I don't know how well you can hear this, but you can actually see that on the rinse valve, this valve is actually clicking. Can you hear that? So, we've obviously got a board issue. It's not providing enough power to power that valve. What I'll do is, the wires, that valve, these wires here, which then go onto the connector milk valves. So we'll just have a look on there. Doesn't seem to be any sort of burning or anything. So what we'll do is, we'll power the machine down. That air valve is, I don't know if I can see in there, is the purple wire. So the purple wire on this one is the end one. So hopefully it might be that end diode. So we'll shut the power down and we'll go from there. Getting interesting this is, it's not just a simple valve fail. So we'll shut that down. So what we've done is we have disconnected the cable. We've got multimeter in shot. So I'll just grab the probes quickly. And we'll do some diode testing. Now unfortunately these are still in series with some things, but I'm hoping that if we just unplug the plug, one of these diodes should hopefully bring something up. Just a final follow-up, doing some investigation work on this board. What we're getting is we're getting a switched voltage, but we're getting no return. So what I'm going to do is, I've got another one of these boards somewhere. We'll dig it out, fit it, and see what happens. Because I can't see any wiring issue, and there's no issue with the valve. So it's obviously got an issue with the board. But the problem is, how long do you spend looking for a fault when you could just put a new board in and then I get a spare half an hour, maybe 40 minutes, have a play with this broken one. So yeah, that's all for part one. Part two will be later when I found the board and get it fitted and ready to go. So yeah, thank you very much for watching and goodbye.